So here we'll look at the different laws of exponents. So we'll start with, what is an exponent? Well, exponents look like a to the n. And what this means is we're going to multiply the number a by itself n times. We call the number a the base, and the number n is the exponent. For example, 7 to the third power is 7 times 7 times 7. 7 is our base, and 3 is our exponent. 4 to the sixth power is 4 times 4 times 4 times 4 times 4 times 4. This time our base is 4 and our exponent is 6. We do have a couple of things we want to watch out for. One, if we look at something like 3 times 2 squared, this is equal to 3 times 2 squared is 4, which is 12. So it's important to do your exponents first. This is not 3 times 2 squared is not 3 times 3 times 2 times 2, which would be 9 times 4. That's very bad. In addition, we want to watch for negative signs. So for example, something like negative 2 to the fourth means negative 2 times 2 times 2 times 2. However, if I put parentheses around that negative 2, this is negative 2 times negative 2 times negative 2 times negative 2. The main difference here, the first one is negative 16. The bottom one is positive 16. So our first rule says that anything to the 0 power is 1. For example, 5 to the 0 is 1. Negative 2 to the 0 is 1. Negative 3 to the 0 without parentheses is negative 1. In addition, 4 times 6 to the 0 would be 4 times 1, which is 4. Our next rule is negative exponents. So if you see a negative exponent, that's the same thing as it being on the bottom of a fraction. For example, 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. 4 to the negative 3 is the same thing as 1 over 4 cubed, which is 1 over 64. X to the negative 5 would be 1 over x to the fifth. Our third rule says if we multiply two things with the same base, we can add their exponents. For example, x to the 7th times x to the negative 2. This would be x to the 7 plus negative 2, which is x to the 5th. Our fourth rule says if we raise an exponent to another exponent, then we multiply. For example, x cubed to the 5th would be x to the 3 times 5, which is 15. If we have something in parentheses raised to an exponent, it's important to raise everything to that power. For example, x cubed, y to the fourth, all squared. Well, we should do x cubed squared and also y to the fourth squared. Our last rule says we would multiply these exponents. 3 times 2 is 6. 4 times 2 is 8. If we're dividing two exponents with the same base, we can subtract their exponents. For example, a to the third over a to the negative 9. Well, this is a to the 3 minus negative 9. And the double negative becomes a positive, 3 plus 9. So this is a to the 12th. Our last rule says if we have a fraction inside of parentheses, we raise the top and the denominator to that power. For example, x cubed over y to the fourth squared is the same thing as x cubed squared over y to the fourth squared. Multiplying, 3 times 2 is 6, and 4 times 2 is 8. Now let's do a few more complicated examples, like this one. So when we have something like this, it's important to take it piece by piece. We'll start with the letters, or the individual letters. For the x, I see a 9 on the top and the 3 on the bottom. 9 minus 3 is 6. For the y, we don't see an exponent on the bottom, which means the exponent is a 1. Negative 2 minus 1 is negative 3. And whenever we are dealing with these, we don't like negative exponents. So we'll move this to the bottom and make this x to the 6th over y cubed. With this one, we'll start by getting rid of the parentheses. We should raise everything to the negative 3 power. X to the negative 2 to the negative 3. We will multiply the exponents. Negative 2 times negative 3 is 6. I then have a 3 to the negative 3. Y to the negative fourth to the negative 3. Negative 4 times negative 3 is positive 12. Since we have a negative exponent on the bottom of a fraction, we can move it to the top to make the exponent positive. And finally, 3 cubed is 27. So we have 27 x to the 6th over y to the 12th.